Hello everyone. So in this class today I am going to discuss heterocyclic compounds. Heterocyclic compounds. In these heterocyclic compounds today we have to know about just properties and importance and the structure of heterocyclic compounds and their examples and first we know about the definition of hetero and cyclic first. Hetero means different atoms we have to see in cyclic form. So cyclic form means that cyclic means it look like a ring form. So every aromatic compounds have different atoms with carbon atoms. So for suppose now we see definition. So hetero atoms among carbon atom. So that we call as heterocyclic compounds. Okay, heterocyclic compounds. So now we see with example first. So example is means now bond with carbon bond with the hydrogen bond and carbon bonded with or carbon bonded with the nitrogen and carbon bonded with the oxygen. So this type of bonds means we have to see just alkyl group. This is aromatic compounds. So every atoms have different properties and different characters. So it will shows some different properties and different kinds of things also. So now we see this is example and next structures of furans and pyrrole and thiophene. These are thiophene. So before we are going to discuss about furans and pyrrole and thiophenes, now we know about the heterocyclic compounds importance. So I already told you now. So HC in the short form cut heterocyclic compounds is HCC. So nowadays it is mostly important for the making new materials and like always medicine in medical field like vitamin B, C or B complex and proteins, carbohydrates, everything is totally built with heterocyclic compounds. So now we see structure of furan and pyrrole and thiophene, and then we discussing so far structure of this among these furan and pyrrole and thiophenes. So we know aromaticity about among those compounds. Now this is a cyclic. So all the carbon atoms being with a cyclic form. So with a different means hetero compound. This is a hetero atom. Z is hetero atom. So here H and CH, H and H. So this is a heterocyclic compounds example. So when we place in the place of H we put oxygen and sulfur and nitrogen, NH. In place of H, NH we place on it, we call as pyrrole, and in place of NH we place it oxygen, it is a furan, and in place of sulfur adding it will be like thiophene structures. So now we see the resonance structure of furan. So among those three, these are similar with furans and thiophenes, pyrrole. So but different in aromaticity. So now we see aromaticity about this. Then after we see resonance structures. So aromaticity rules तो क्या हो गया means aroma means it pleasant smell. So city means like it explain about ring form. So whatever we have carbon and hydrogen here, this is a furan. So it will be it will follow sometimes aromaticity and non-aromatic compounds are are either non-aromatic and non-aromatic. So that means these are furan structures we have, and this is a pyrrole structure. So cyclic dienes means cyclic compounds. These are furans and pyrimidines. So nitrogen is more electronegativity than the oxygen. That's why it is more stable than the pyrrole. And according to our rule, so benzene is greater than, pyridine is greater than, benzene is greater than, pyridine is greater than, and pyrrole, and next furan and thiophene. This is a rule, or this is the order of aromaticity. Next, resonance. Resonance means the delocalization of pi electrons in the cyclic form. So now we see aromatic example is the furan here. So this is the electron, the lone pair electrons goes to this side, so it will form bond and here carry positive charge. So now we see detailedly. This is a resonant forming furan, is the main starting material furan. So here lone pair electrons goes to here, and this bond will goes to here side. So when we nomenclature of this furan, so this is a main functional group, means main categories are 1, 2, 3, 4, 5, 6. So it will be like that. And रासे
ठीक है. तर
कदर ये